All right, guys. This one won't be very long at all. We'll tackle a couple of these and kind of walk through them, and then we'll let you guys get going. I'm trying to make these short so they don't take nearly as long. All right, so we have two new derivative rules. One has to do with e to the x or e to the u. So this is like an e to the x if you want to look at it that way. So this is e to the x. And this is like about the natural log of x. So we'll tackle these here. So when we take the derivative of e, it's e to the u. So it's basically itself times the derivative of u prime. So what's ever up here. So if we're looking at this, we're going to take the 2 just stays out front. We're going to take e to the u, which is itself. So that doesn't change, and we're going to multiply it by u prime. This is u, so u prime is going to be 4/5. Now, if you're not sure how I got that, don't forget that we let u equal 4/5 x, so therefore u prime is 4/5. So that's 4/5. So then when we multiply straight across, we get 8/5 times e to the 4/5 x. And that is our derivative of e to the x. So really all we're worried about is what's up in here. This stays the same. So when we move over to the natural log of u, it's the same idea. We're going to say, we're going to let this equal u. So 2x to the third equals u. That means u prime is equal to 6x squared. So if we work with this, that means that y prime is equal to 1 over u is this one, 2x cubed, times u prime, which is 6x squared. And then we could probably clean this up, which would be 6x squared over 2x cubed, which is going to be, that's a 3, those cancel. That's my value of the natural log of x. Okay, so go back through it. E to the x, e to the u stays the same. Then we take this as u. We find u prime. We put it here. We clean it up. Natural log derivatives. We assign this as u. Find u prime. Put the two together. Clean up the fraction. So those are pretty straightforward. Now the only thing we've got to watch out for is when they add other layers to this. So I'll just leave those two formulas up there. And then this is one of the things I've been working on with people in office hours. What to do, what rule to use when. So if we have this, let's say, if we have something like that, got to make sure this is a product rule. And this is a product rule. So you have to find the fact that x cubed is your first term. The derivative of that is that piece. E to the x, its derivative is e to the x. So we end up multiplying these two. So x to the third, so this is u prime, this is v prime, if you want to look at it that way. We're going to take x to the third and multiply it by e to the x. We're going to add that to 3x squared times e to the x, and we're going to subtract that from the product rule that's over here. The reason I write this in brackets is we got to keep track of that negative. So x is our u on this side. U prime is equal to 1. Then we have e to the x and e to the x. So x times e to the x and plus e to the x. Now we just got to clean all this stuff up so we get this big long equation with the distributed piece in there. So our y prime is x cubed e to the x plus 3x squared e to the x minus x e to the x plus e to the x. Oops, sorry, minus e to the x, because we got to distribute that piece in. That's why I put the brackets there, and then I ended up messing it up. So that is how you tackle that. So the derivatives themselves aren't hard. What I'm finding out where we're struggling, and this is typical, guys, is that when we're looking at a problem, we don't know what to do. So when you see stuff like this, including our sine, our trig function ones, you have to look for the e to the x's and their ability, sorry, not the e to the x's, the multiplication pieces that are product rules. Look for quotient rules. So you may have to do a certain rule here and a certain rule here and then combine the two. It may be a chain rule. It may be a chain rule and a quotient rule. It may be a product rule with the chain rule inside of it. So watch out for those. Come into the office hours. We'll see you in class today. Good luck.